Okay, so now that we know what rational expressions are, one of the first things we have to do is be careful about a division by 0. So let's imagine, let's go back. Right, here's an expression, x plus 5 over x minus 2, and I want to evaluate it if x is equal to 2. So again, to evaluate, I simply substitute the value that's given into the expression. 2 plus 5 is 7, and then 2 take away 2 is 0. And that situation is undefined. Even if you try doing it on your calculator, right, 7 divided by 0 is going to give you an error. Mathematicians don't quite know what to do with that. It's undefined. So because we are dividing by polynomials, we have to worry about what value of x causes a division by 0 for this one. What value of x causes a division by 0 on this one. How about here and how about here? So that's one of the items we have to concern ourselves with rational expressions. Because we're dividing by a polynomial, we have to avoid those values that make a division by 0 possible. Sometimes it's real easy to see that, like on this one, I think even before I plugged it in, you guys can see that 2, right, it's not going to work. Right here you can probably see it's just going to be negative 2, and right here it'll probably be 0. But what about when it gets harder, right? How do we figure out what values do we need to throw out? And so ideally what you do is you take your expression and you set the denominator equal to 0. Let's find the situation that makes it undefined. And if we add 2 to both sides, there's the value that we're trying to avoid. As a matter of fact, we don't want x minus 2 to equal 0, which means I don't want x to equal 2. So here's what I don't want to happen, and let's figure out the value that makes it happen. And then we have to start throwing that out. So this basically says for this expression, I can use any number I want as long as it's not 2. The evaluation will come out with some value. All right, so right here, if we kind of follow that, again, I know some of you can say it's 0, but officially, right, I do not want 6x to equal 0. So if we tried solving that, I divide both sides by 6. Now 0 divided by 6 is defined, right? Anything 0 divided by anything is just 0. So the value that we have to throw out of this expression is 0. Again, any value will work with the exception of 0. 0, 6 times 0 is 0, giving us a division by 0, which we're trying to avoid. So restricting, all right? There's a restriction. So anything but 0. Okay, for the next one, again, I think you can just by inspection observe that negative 2 is a bad value. But again, to be consistent, what I'm trying to do is avoid, I do not want x plus 2 to be equal to 0. If I subtract 2 from both sides, then the situation we're trying to avoid here is negative 2. So for this expression, x can be anything I dream up as long as it's not negative 2. Because negative 2 makes the denominator equal to 0, which causes a division by 0. Which is bad news mathematically. All right, and so that process is going to be important for the next one, right? Because here it's kind of, maybe if you're really good, you can kind of come up with a value, but what values of x, right, are we restricted to? What can we not be equal to? So we'll start off with that expression. I do not want this expression to equal 0. And then how do we solve a polynomial equation? Well, at the end of chapter 5, we learned to factor. Let me use guessing and checking. When I do a guess and check here, first times first is first, last times last is a negative 6, and I believe the combination I want is that. Doing a real quick check, the outer is a 2x, the inner is a negative 3x, giving me that inner. So there's my factorization. Zero factor property now is in play, so maybe the x minus 3, we don't want that to be 0, or maybe the x plus 2 is not equal to 0. Adding 3, one of the situations we have to avoid is 3. Subtracting 2, the other situation is we need to avoid is negative 2. So there's 2 values. All right. Again, for this expression, I can use any value of x I want, but I have to throw these 2 out. X cannot be 3, or x cannot be negative 2, because those 2 values make the denominator equal to 0, which is bad news. Right. We want to avoid the division by 0. One last one. Again, this one's really hard to see. What values of x do I have to restrict myself to? And again, if you're following the process, we're going to start by just asking ourselves the question, when does the denominator equal to 0? And then solving this, we again are going to try to set up the zero factor property. Let's see if I can guess right here. So the first times first is 2x. I believe that might be a -4 and a +1. Right? So my outer is a -8x. My inner is a +x, giving us the -7x. So there's my factorization. Zero factor property now says that, well, maybe this is the guy that's not equal to 0, or maybe that's the guy not equal to 0. Let's start here. That's a little easier. So one of the values we're trying to avoid is x cannot be 4. Right? That's a value that we have to throw out. Right? So we can be anything we want but 4. Over here, if we subtract 1, we get that 2x is not equal to -1. Divide by 2, and there's our other situation. So again, in the whole scheme of things, there's a infinite number of real numbers. You can use any real number you want on this expression, but avoid 4 and avoid -1/2. Those two values cause the denominator to be 0, which we're trying to avoid. We're trying to avoid the division by 0. So that is one of the things that we have to pay attention to with rational expressions. We want to avoid values that make the denominator equal to 0. Okay, so there's your first item. More coming up.